The objective of this teardown is to see what failed, how it failed, and figure out what kind of laminations they had in there, and see what we could deduce, how they might have done things, see if there's any salvageable parts, what you could really pull from this, what could be used in some other project, and zoom in close into the screen and whatever else might be interesting. See the pixelation on the screen, see if the colors are visible. Dell monitor, strangely enough, turns out I had a really old monitor with exactly the same model number screen. This one died. This is already replaced. What I'm going to do is strip the old screen that came from this monitor, this Dell monitor. And basically there's some coloration problems, and it's pretty clear if you look at a picture of the screen where there's some definite desponding or some chemical changes that occurred. This is a picture of the internal the monitor, the driving board for the power supply, and the high voltage is on the left hand side, high voltage section on the extreme left, power supply in the middle there. The connections for the board itself, the VGA, is the third piece there, well it's already the second board, and then the following piece appears to be tied into the USB. The screen from the Dell, if you look carefully you can see there's definitely some issues. So I pop it out, take a look, see how it's built. This would be impossible to fix. It's not even trying to fix it, just trying to understand what the different lamination layers are, how they managed to get the backlight. It's a high voltage supply it's sent in here, so what exactly it is it an EL backlight? How does it work? Does that still work? Can I power that up? Alright, this is the back of the screen to open. As you can see, the sides are relatively, should be easy, just a matter of firing off these edges and opening it. I haven't put on the light, let me see. Yeah, it's a little bit easier to see now, these little color variations. So this outer housing stainless steel, it looks like, should be relatively simple to do. Right, initial cover popped off, which is the back there, stainless steel cover. The back here seems to have some ribbons going across, so I take it that probably some data channels. We'll check that out. This side has some tabs, and the rest of sides, well, isn't very much to it. It really is just the plastic clips. Right, so this here had two screws, one, two, pretty fine screws. So taking that out, what we end up with is, well, pretty well made board actually. Nice gold plated contacts. Some contacts clearly left out. I don't understand why it was maybe simpler to just run these across. But considering what it was designed for, one would have assumed that they could have just left these out. I'm not sure why. Some processing unit and a bit of information here. I'm going to get a close up on this so we could see what this is. Possibly a power regulator. Not exactly sure what that is. So I'm going to get some close up shots. Look at this here. Test points. Some information written down. Again, as I said, this, not sure why they would do it if it wasn't intending to put ribbon there. The model number, all of this is gold plated. Chip, I guess power, I can have to investigate that. Some more information printed there. Another set of what appears to be test contacts. Some test contacts here, a bit of testing. Not too bad quality board. Side of it, nothing to talk about, really just some traces. Can't really tell how many layers. It's a pretty thin board. I'll have to measure that to actually tell what it is, but it's a pretty thin board. But I would assume, well, maybe not, maybe it's just double-sided. I've seen a lot of them here, and possibly no, these come out from different locations. There's at least a layer or two inside here. Right, so looking at this, this is the other side of the reflex ribbon. I don't know what these things are. There's one on each one of them. Can't just be a spacer. Well, maybe it can actually, but I don't know. I mean, it does look like silicone. I don't know what exactly it is. Interesting though. I just open. Let's take a look. One-handed is not exactly the best, but right. So there's oh damn it, that's falling apart. There's a diffuser film that's attached to a couple of tabs. That's interesting. There's the background here, and there's definitely, I don't know if it's heat, what it is. I don't know why this looks that bad. So we investigate this a little bit better, see if anything could be done to it. Probably try to figure out what kind of coating that is. Well, that's interesting by itself. Right, another plastic layer, half semi-silvered. Not really sure what this one does. Interesting. Another plastic layer, kind of looks like a diffuser. My guess would be a diffuser on that one. Right, and then this appears to be glass. Right. Oh, I'm probably going to need both hands to get into that. But maybe the honeycomb pattern is visible, maybe it isn't. There's a honeycomb pattern and this is glass. So I'm going to take a look into that and see what this does. I should get this out. This is actually a piece of flexi. It's pretty thick, looks straight, thereabouts. Two white pieces on the side. As you can see, diffusion based pattern on it, and I could feel this with my hand, so maybe it's stuck on. I don't know, maybe it's blasted on, sandblasted. It's a little rough. Some other etching process chemically, I guess. This side is perfectly clean, nothing. Yes, it's just a smooth, again, plexi. So that's an interesting method. And then the lighting is based upon fluorescent tubes. I'm not sure if this is visible. Yeah, you can clearly see it's a fluorescent tube here. Actually, there's two tubes on that side and two tubes on this side. And I'm going under the assumption it's fluorescent, but it may well be yellow. Let me see, is it focus here? There's a high voltage system for generation, so who knows. Some further investigation into exactly what this is, how it tricks, what it is. It bends, so I don't know. I wouldn't think it's fluorescent, but it's two on that side, two on the side. So essentially, light comes in, you have that grating, and you have the reflection from this, and you try to get a uniform surface. From that, it then goes on to this layer, which diffuses it further. As you can see through it, but it's diffusing. Then it goes to a semi-silver layer. As you can probably see my fingers. Yeah, you can see my fingers straight. So it's a half mirrored kind of thing to reflect back, and I guess get a more uniform distribution. Then we go to another layer. That's plastic. That's just take it on. Probably gonna pull that out. And this layer is actually the LCD layer. So it's actually LCD. That's bad. I would expect that this is a glass. Yeah, it looks glass. Right, if you look carefully, it looks like it's glass. So yeah, this is the actual LCD. Has failed. No possibility of that being fixable. Nothing could be done about that. That's at the whole LCD itself a little bit further now. This is some little silicone rubber seal I've had. Frame has been knocked off. Yeah, as I said, it's dead. It's not. There's nothing in this is salvageable. But this is, as I said, glass as expected. This is visible, yeah. And some coating on the front. can't say it's the coating alone that's bad, because if you look at it, that's a plastic coating. Some plastic coating on the front here, but it really is, as I said, quite messed up. But maybe you can make some sort of light out of those things. I still have to figure out what these are. This is the other side of the same thing I was shown. I really still have to figure out what those are. Just flipping this over. That's these things. What the heck are they? Beyond that, I don't know. I still don't understand why some sections aren't pretending swelling at this point. Anyway, as I said, this screen is dead. This is it reassembled. Couple little specks have got incorporated by mistake. Tried a microfiber cloth, but yeah. So this is everything except the actual LCD screen. So yeah, I should get a brightish light. That might make an interesting project to make something with a backlight. Some quick views of the monitor contacts and other things zoomed in. It's amazing how nice and fine and crisp these contacts are, these lines. Again, similarly, lines shown here, again, crisp lines. And this is another shot with it showing just how fine these things are. This was my mystery part. Turned out it's not very much of a mystery. It's an inductor. It was labeled as L1, I believe. So yeah, not much of a mystery there. This is the screen, the back of it, showing the contacts and gridded network. Well, this is a USB microscope, so obviously the LEDs are reflected on the surface. Not much I could do with that. If I take them off, we don't see anything. This is the same surface, again zoomed in pretty close from the other side, and this is the same surface now with the light off from the top and with an LED light shone through it, and it's quite clear. The red, green, blue, the pixelation is perfectly clear. It's odd that it looks a little crinkled. I don't know if that's how it's supposed to look, if it's because of the age and problems with the layers. As we know, this monitor has problems. Not sure, but it's clear cut lines, clear cut pixelation. Interestingly, the lines are thicker in one direction as opposed to the other. You would think in a gridded system like this, they would both be as thin as possible, but between the colors, you tend to have the lines look a lot smaller. And well, between the different, well, we don't know if it's rows or columns here. We really can't tell from this orientation. And this is finally my object that I have no idea what it is. As I said, it sort of looks like it's a silicon component potted with epoxy. Lines coming on one side at one thickness and leave at a much finer thickness on the other side. I honestly don't know how, what's the purpose. Really have no idea what this is, and if anybody knows, I would definitely like to know. Please do put this information in if you know.